Hello once again students, welcome to iTTV's lesson of Biology Form. Wow, respiration is quite fast, isn't it? It's quite interesting. Now, we've already seen all the gases exchange, we saw the transport, there was lots of complex ideas involved in it. Now, like I promised you, we're going to take a look at the regulatory mechanism of both oxygen and carbon dioxide. So now we need to know, we're trying to understand what is it that causes the amount of oxygen and carbon dioxide to be kept constant in the body. Alright? So if there is too much of carbon dioxide, problem. If there is too little oxygen, problem. So remember, too little oxygen, problem. Too much of carbon dioxide, problem. Okay? So we want to keep the oxygen amount at very high levels. That means the saturation of oxygen in the human blood has got to be 100%. Alright, it's got to be 100% fully packed. Our body's got to have full amounts of oxygen. If at all the saturation level of your oxygen in the blood reduces below 80, you are in terrible trouble. The person can go into a coma, they can lapse into a coma, and they probably can die. Alright, so we want to see how the mechanism works. Let's take a look now. So while we start this section of respiration chapter, we've got to well define two different things, breathing and respiration. So before you now you can see that the rate of breathing is directly proportional to the rate of respiration. Students, where does breathing occur? External. Slow breathing rate. What about a high breathing rate? That's a high breathing rate. Okay? Next, what is rate of respiration? Can I see it? No, you cannot see it. You cannot probably experience it directly firsthand because the respiration that we are talking about occurs in the cell. So the amount of which energy is produced in the cell determines the rate of respiration. So if there is more glucose being oxidized, rate of respiration is higher. If there is very little glucose being oxidized, the rate of respiration is lower. Now, can you tell me when is the rate of respiration in your body the lowest? Is it when I eat? No. When I'm eating, I'm chewing. Enzymes doing work, digestion cannot be high respiration rate. Is it when I'm walking? Running, higher respiration rate, walking. But I still use energy. When I'm resting watching TV, my eyes still functioning, I'm still getting stimuli, I'm responding towards the stimuli, I'm laughing at a joke, I'm crying when there's a sad scene. When is the rate of respiration low? I got it. When I'm at sleep, right? So when you are asleep, is your body fully, has your body fully shut down already? Is your brain not functioning at all? Wrong. It is working, but it's working at a very basal rate. So we call that as a basal metabolic rate, BMR. Basal metabolic rate is the amount of energy that is needed to keep you alive. That means respiration, peristalsis, brain activity, and stuff like that. Okay? So the rate of respiration will increase when you do activity. What about vigorous activity? Say when I'm running up a hill, I'm in a marathon, or when I'm running a 100-meter race, I'm carrying boxes to shift my house. These are vigorous activity. When you do vigorous activity, your demand in the muscles for oxygen increases. So what happens? To compensate for that demand, your rate of breathing will also have to increase to bring in more oxygen. You get the idea, right? So let's continue. We'll see a little short notes, then we'll try to go for the explanation. The rate of respiration is increased because of vigorous activity. During vigorous activity, the oxygen and glucose need of the cell increases dramatically. This reduces the oxygen content in the body and begins the accumulation of carbon dioxide in the bloodstream. In response to this imbalance, the breathing rate and heartbeat rate of the body increases. Pay attention that the rate of breathing is directly proportional to the rate of respiration. There are a few facts written for you. A normal breath and heartbeat rate, that means a normal breathing rate and a normal heartbeat rate, is given to you at 16 to 18 breaths per minute or 60 to 70 heartbeats per minute. This occurs only when a person is at rest or when the person is at sleep. However, during vigorous activity, there shows an increase in the breath and heartbeat rate. The breath rate will go up to approximately 30 breaths per minute. The heartbeat rate can easily reach 120 beats per minute. With that, let's see the causes of the increase in breathing rate. 3 basic factors: vigorous activity, which is the key, fear, and the sense of emergency increases the breathing rate in humans. The breathing rate in humans is increased by 2 systems which govern and control the breathing rate. First is the nervous system, which is held by the respiratory center found in the medulla oblongata. Next will be the endocrine system, which involves the usage of a gland called the adrenal gland, which is placed just above the kidney and secretes the hormone called adrenaline. Now we know that the breathing rate can be influenced by the nervous system and the endocrine system, right? So the nervous system will send out charges and allow the breathing rate to increase. However, the endocrine system will work quite slowly, but it will eventually work to alleviate your body metabolism and so on and so forth. And this is done by the secretion of hormones. So now it comes to the question once again. I still haven't answered how is it that the body regulates the oxygen and carbon dioxide level, right? Okay, so let's take a look at this concept without the slides. Let's take a look here. So now I'm going to show you that there are 2 respiratory gases which are involved. One is oxygen and the other is carbon dioxide. Now the level of oxygen primarily should be higher. This is what your body wants. But the concentration of carbon dioxide should be kept low. This is what the body wants. But now say I am carrying out vigorous activity. Okay, vigorous activity such as running. Okay, so when I am carrying out vigorous activity, what happens is the oxygen demand in the cell increases, right or not? Good. Now, when cell respiration increases, the demand of oxygen increases. This causes the oxygen level to drop. But then, as a result of cell respiration, the carbon dioxide level will increase. Correct or not? So, thanks to vigorous activity, the level of carbon dioxide increases and the level of oxygen in the blood decreases. Can your body say, it's okay, so what? When we stop the vigorous activity, everything will be back to normal. Can that happen? No. Why? Because this will reach to dangerous levels and the person can die. So now, what happens is, your body needs to do something quick. Now check this out. Say for example, I give you 2 tasks to do. I'm telling you, boys and girls, oxygen level must never be low. Watch the oxygen level. Then I also tell you, while you're doing this, make sure you also watch the carbon dioxide level. I don't want it to go above a certain level. Which will you do first? Will you do this or will you do this first? So you see, what happens to us is, we carry out one process, then we will do the other. But when we are doing the other, the drop in oxygen will occur again. So you leave this, you'll go here. But it's not an increase. You leave this, you come here. You leave this, you go there. The problem is not resolved. The body found a superb mechanism way, okay, to control this. How? Watch. Although oxygen is more important in the body, your body don't care about oxygen. Forget about it. Focus more towards the carbon dioxide. Why? You learned in the previous lesson already. Carbon dioxide is an acidic gas. See, oxygen very hard to identify, but carbon dioxide easily we can identify. How? Watch. See here, carbon dioxide is an acidic gas. Correct or not? That means an accumulation of carbon dioxide will cause the pH to drop. Correct or not? So increase in carbon dioxide will cause the pH to drop, become more acidic. So the body just needs to watch the pH. It will just watch the pH. The normal pH for humans are approximately, okay, so this is the normal pH. Okay, small p, big H, okay. The normal pH in humans is somewhere around 7.4. So it's slightly alkaline, that's all. Somewhere around 7.4. The moment the pH drops below this, let's say the pH goes to 7.2, 7.1, oh, you're in dangerous zones already. Why? Your body is quite smart. It will just look for the pH. If the pH drop, the body will know, oh my God, there's too much of carbon dioxide. That means there is too little oxygen. Do you know why? Because oxygen and carbon dioxide are involved in a very close relationship. What relationship? Cellular respiration. So both of them are involved in one process called cellular respiration. That means if the carbon dioxide level is up, the oxygen level is definitely down. We understand that. Get it? So your body, instead of checking for 2, your body will just look for the pH. If pH drop, means got a lot of carbon dioxide. It means there is too little oxygen. So indirectly, the body is controlling everything by looking at the pH. How is the body controlling or watching against the pH? Okay, this part of the story is quite interesting. Now watch. What your body did was, your body put some markers around, some alarm systems in your body. Okay, so we have the nervous system to thank. Now, the central nervous system involves the brain. Okay, now in the brain, there is a part called the medulla oblongata. Okay, the medulla oblongata, students, is a part of the brain. It's a part of the brain. Now see, the brain has got basically 3 parts. One is the cerebrum in the front, then we have the cerebellum at the back, and then we have the medulla oblongata, which is a small structure somewhere at the base of the brain. Okay, we also know it as the brain stem. Alright, now in the medulla oblongata, you remember a story like this. Because it's fun to remember stories. In medulla oblongata, there are 2 houses. Just remember, got 2 houses. Okay, or we call this 2 centers. Okay, all right. One is RC, the other is CC. What are they? RC is respiratory center. CC is cardiac center. So we will learn about this now because it's respiration. So this is the part of the brain which controls or regulates the oxygen and carbon dioxide level. So you see, the cardiac center is not involved now. You will learn about this in Form 5. But I give you all at one go so that it will be more repetition when you go to Form 5. Alright? Cardiac center is actually involved in controlling the blood pressure. Okay? Now, the respiratory center found in the medulla oblongata is in charge in controlling the respiratory gases level in the blood. Okay, now the medulla oblongata or the respiratory center is a place where it receives nerve impulses. Receives nerve impulse from where? The body is very smart. What the body did was, in order to control or to check the pH of the blood, it put alarm systems everywhere. Okay, so what happened is, in your brain, surrounding the brain, we have something called CSF. In the CSF, it will lead to chemoreceptors. Just watch, be patient. See, what is CSF? Okay, CSF is cerebrospinal fluid. Okay, now see, the cerebrospinal fluid, cerebro means brain, spinal means the spinal cord. So surrounding the spinal cord and the brain, there is a liquid, a fluid. Now this fluid will be able to detect the pH change. Why? When there is an increase in carbon dioxide, the carbon dioxide will dissolve and cause the cerebrospinal fluid to become acidic. The moment the CSF is acidic, the medulla oblongata, which has a lot of chemoreceptors. Now the chemoreceptors, which are chemical receptors, they pick up the change in pH found in the cerebrospinal fluid. So immediately the medulla oblongata or the respiratory center in the medulla will know that there is a drop in the pH. What will happen? The brain is already notified now. So immediately the brain will take an action to change this condition. Now sometimes we cannot hope on only one measure. Alright? We need to have plan A, plan B, plan C. Why? Oh, it's a very important process, correct or not? Okay. What if this one never function? See? If never function, what will happen? You will not know the oxygen and carbon dioxide level change and you'll immediately die, right? Your body is smarter than that. What does your body do? It has plan B and plan C. Check this out. Now, say for example, blood enters into the heart. So very fast, I'm going to just basic scribbling of the heart. Okay, very small one. Heart divided into 4 chambers, correct? Okay, atrium, ventricle, ventricle. You learn when you were in lower secondary, right? Okay. Now what happened? Deoxygenated blood. Enter, make U-turn, go to lung. Oxygenated blood will come back and enter inside here. Let me use a different color so that it's easy for you. Oxygenated blood in red comes into the left atrium, makes a U-turn and goes out. Correct or not? Now, the blood that comes out of this part, this is oxygenated blood, correct or not? So can I say that in the entire body, this part of the body, inside this blood vessel, what's the name of the blood vessel? Aorta, very good. In the aorta, there is the most amount of oxygen, correct or not? Logic, huh? Now, can I also say that in the aorta, the level of carbon dioxide is very, very, very low, correct or not? So that means the blood in the aorta must have the most optimum of pH, correct? So what we do? We use this to the advantage. How? Take the chemoreceptor and put in the aorta. Why? Because if there is a drop in the pH, immediately this is the first place to be identified. Send the signal straight to the respiratory center. They will take care of the rest. Okay, you get the idea now? Very good. Now watch this. So we already have the aorta. The aorta is divided into 3. Just watch a little scribbling. Although this is not the exact anatomical structure, but it will more or less help us to understand how the aorta works and functions. You see, the aorta is not one artery. The artery will branch out into 3. Why? Supply oxygenated blood faster to the entire body, right or not? Okay. So the best place to put the chemoreceptor, put here. Put the chemoreceptor here. I'm just drawing a cartoon version of it. I'll show you the real version later. Now what happened? Blood will flow. pH 7.4, no problem. Blood flow. pH 7.4, no problem. No problem. What happens? The person, the individual, starts to run. He starts to run. He starts to run vigorously. So now vigorous activity taken place, oxygen is being used up more in the body. So blood flow here. 7.4, 7.4, 7.35, 7.3, 7.28, 7.27. The drop in pH is too much already. Which means what? There is too much of carbon dioxide. Which means what? There is too little oxygen. So immediately these chemoreceptors, they'll pick up the stimuli. Understand? Once they pick up the stimuli, they will send the impulse directly to the respiratory center. Can you see? So what the respiratory center will do? The respiratory center in the medulla will send out impulse. Send out impulse. Where? To muscles. Respiratory muscles. So the muscles in the respiratory system. Example, external intercostal muscle, inner intercostal muscle, and the diaphragm. This guy will say, alright guys, start working at a higher rate. Why? Because if they work at a higher rate, they will expel a lot of carbon dioxide, they will take in a lot of oxygen, and the balance will be back to normal. Correct or not? So now what happens is, the muscles which are intercostal and diaphragm, remember, these muscles will undergo increased rate, okay, an increased rate of breathing. Okay, remember we saw in the beginning, increased rate of breathing, this is when it will happen. It will lead to a concept known as hyperventilation. Okay, it will lead to hyperventilation. So, when the person was running, pH dropped because accumulation of carbon dioxide, chemoreceptors in the aorta or the aortic arch picked up the stimuli in form. What happened? The respiratory center in the medulla oblongata send impulse to the muscle in order to contract and relax faster, increase the rate of breathing. Hyperventilation occurs. What is that? So at the end of the 100-meter race, what will happen? The person will start to pant. Hyperventilating is panting. Take in a lot of oxygen, exhale a lot of carbon dioxide. You get the idea? It's quite simple. Now, what if this malfunctions? Don't worry, your body has got plan C. What is plan C? Let's see. In the entire body, you tell me, in the entire body, which is the number one organ, the most important organ, the big boss who controls everybody else? Who is it? The brain. He is the think tank. He is the important guy who controls the entire body, correct or not? So let's say your body goes into some kind of emergency. What will your body do? Your body will say, alright guys, hands, legs, you guys are not important. I'm going to cut oxygen supply to you, but I'm going to make sure the oxygen reaches the brain. That's why people who go for mountain climbing up in a very cold environment, or people who are lost in a very icy place, alright, snow, what happens is they end up getting frost bites in their fingers and toes. Frostbite. Does frostbite occur at the neck? Does frostbite happen at the head? Frostbite will only happen at the extremities, meaning fingertip, toe tip, the edges of your ear, the tips of your nose, the tips of your lips. Why? Because the body will say, okay, if we send the oxygen to these parts of the body, there will be a lot of heat being lost. So we conserve the heat inside here. Let the vital organs survive. Now you are entering survival mode. So what your body will do, supply the heat or the blood to the brain. So long story short, what it means? It means that no matter what happens, your brain will get the oxygen. Correct? It will get the oxygen. That means the blood which is flowing to the brain, the artery, the artery here which is going to the brain, this artery will have high concentration of oxygen or not? Will have low concentration of carbon dioxide or not? Will have the most optimum of pH or not? Yes. So what do? Put a receptor here. If there is a change in the pH there, you will be the first to know. Correct or not? Very smart idea. So the second part of the body will be these arteries. The one we saw just now was known as the aortic arch. The one that I'm telling you now is the carotid artery. Now, carotid artery take blood to the brain. Jugular vein brings blood down back from the brain. Carotid artery and the aortic arch. Cool? Now tell me, I have a very quick question for you. 3 places where I can find chemoreceptors in the regulation of respiratory gases. Number 1, medulla oblongata. Number 2, aortic arch. Number 3, carotid artery. Cool? Very good. How does, next question, how does the respiratory center in the medulla oblongata regulate the amount or the level of respiratory gases in the blood? By sending out impulse to muscles involved in the respiratory system. the muscles such as intercostal muscles and diaphragm will be made to increase in their contraction and relaxation, therefore allowing the body to hyperventilate. Hyperventilation removes carbon dioxide in large quantity and returns oxygen in large quantities. Can you see how we are going? Very good. So now this is just a basic simple representation for you. Now let's see the real deal. Okay, I'll show you the diagrams. We'll speak it along, listen, observe. Is good enough for you already. Okay, let's take a look. The diagram before you shows the location of respiratory center. So the chemoreceptors that we were talking about are divided into two: the central chemoreceptors and peripheral chemoreceptors. Can you see the position of the respiratory center in the brain? It is found around the medulla oblongata. Now, it is in this medulla oblongata where the central chemoreceptors are found. They detect the change in pH found in the cerebrospinal fluid. Next diagram, you can take a look at the location of the peripheral chemoreceptors. Now, the peripheral chemoreceptors are kept in two locations, and the chemoreceptors are contained in a body known as, first, the aortic bodies found in the aortic arch. Can you take a look? Good. Next up will be the carotid bodies, which are found at the carotid artery of the human being. So you can observe that as well. Now these two bodies, the carotid body and the aortic body, contain peripheral chemoreceptors which pick up the change in pH, or which picks up the drop in pH. Now students, always be reminded that the drop in pH symbolizes the accumulation of carbon dioxide gas, which in turn symbolizes the drop in oxygen level in the body. Next, let's take a look at the mechanism itself. Can you pay attention to the carotid bodies and the aortic bodies? Because that's where we are starting the story from. The carotid body and aortic bodies pick up the stimuli, which is a drop in the pH of blood, thus sending impulse to the respiratory center found in the medulla oblongata. At the same time, chemoreceptors found around the brain also pick up the change in pH from the cerebrospinal fluid. An impulse is also channeled to the respiratory center. The respiratory center then carries out a response by sending out impulse or electrical charges to muscles found in the respiratory system, such as the internal and external intercostal muscles and the diaphragm. Upon receiving impulse from the respiratory center, the intercostal muscles and the diaphragm contract and relax at a higher rate, thus causing the rate of breathing to increase. This causes the body to undergo hyperventilation, which exhales and releases a large quantity of carbon dioxide from the body and replenishes the oxygen level in the body, thus returning the levels of respiratory gases to its optimum and normal level. The blood pH will return back to approximately 7.4 pH. Now dear students, there is one more fact that I've got to tell you. You see, sometimes when you are climbing up a mountain, say for example, or you are at very high altitudes, at a higher altitude, the atmospheric pressure will drop. We saw this previously. I told you that the atmospheric level at sea level, okay, the atmospheric pressure at sea level is 760 millimeters mercury or 1 atm. As you go up, the air pressure will drop. As you go down, the air pressure will increase. Correct or not? Okay. So let's say you're climbing up a mountain. When you're going up and up and up in altitude, okay, what will happen is the air pressure will drop. Therefore, the partial pressure of oxygen will also drop. So at these conditions, what will happen is you will have a deficiency of oxygen, but the pH will still remain almost normal. How is your body going to know that there is a drop in oxygen? You saw the problem now? In normal condition, you work vigorous activity, you work hard. Carbon dioxide is a lot, so oxygen is used up. You get the idea? But when you're climbing up a mountain or increased altitude, you don't do vigorous activity, but still the oxygen level is low. How does your body recognize this? Simple. When the oxygen level goes very low, then what will happen is the respiratory center will directly pick up the change in oxygen level. Okay, so that is another fallback effect. So what will happen? The respiratory center immediately will carry out the response for that situation. This is a very important part. Make sure you revise this again and again. So until we meet again in the next lesson, that's all for now. Thank you for watching iTTV.